Recording will start soon. You are recording.
Great. Okay. Hello, everyone. Again, I'm Robbie McElrath. I work for Google on isolated web apps, which is what we're going to talk about. So we're going to go over a little bit about web APIs in general, related to isolated web apps, talk about what they are, what they get you, how they work, then talk about their current status, how you would make IDOA on APIs. Okay, so to start with, we want to make a new web API. Great. As Chris said yesterday, you should be following the tag design principles. It's a relatively short doc. Recommend it. It's a good read. There are two principles in particular that I want to call out because they tend to come up when you're dealing with powerful APIs. First is it should be safe to visit a web page. Obviously, you should not be breaking web security primitives if possible, and your API should not be abusable. If it's not safe, fix your API. Limit its scope, try to solve it a different way, make it safe. Or maybe we can change the web platform. We did this with cross-origin isolation, which was a platform-level primitive that we added, which allowed us to enable shared array buffer and other features that could be used to launch side channel attacks without cross-origin. The other thing that I want to call out is ask users for meaningful consent. If you're going to do something fancy, users should understand what you're doing. If they don't, figure out how. It's not really a good way around this. You can possibly put the feature behind enterprise only and rely on the admin to grant permission, but that's not great either. A good solution here is a good example of addressing this is user-based permissions, which we've started using more in the last decade or so. Things like file system access lets you choose folders for devices, specific device. That both helps users make a meaningful decision and also narrows an API and makes it safer. So these have all led to us being able to expose a lot of more powerful APIs over recent years, but there are still others that we have not been able to bring to the web, which most of them run into one of these two limitations. So, okay, what if you can't figure out how to make your API safe? Try again. Work hard enough, you might be able to find a way to do it. But okay, let's say you did that. You still can't make it safe enough. Some problems that developers have, as far as we can tell, cannot be solved with an API that is appropriate to expose to arbitrary web content. Okay, but what about non-arbitrary web content? If you know exactly what code is going to use the API, and you can look at it, then you could make statements about it. Statements like, I'm an enterprise admin, I know what this code is, and I'm comfortable with this code accessing this other API. And that brings us to isolated web apps. I will probably be calling them IWAs out of habit. So what are they? At the most basic level, the way I think of them is they let you know what an app is going to run. And importantly, if you know what code is going to execute ahead of time, you can audit it. And if you can audit it, you can make attestations about it. Now, depending on the API, if the risk, so okay, if you make attestations about an API by examining the code that uses it, that might be enough to mitigate the risks of a given API. To phrase this in another way, if you can't statically prove that an API is always safe to access or that a particular usage is safe, and you can't reasonably ask the user, then the trust signal for actually enabling that API has to come from somewhere else. If someone else can vouch for the code, that's great, but you have to know that the code that is being vouched for is the same code that you are running. And that's one of the most important properties that isolated web apps can provide. So how do they do that? Well, for the most part, they're mostly the web. They are as webby as we can possibly make them. So they have a pile of web-looking resources. They have a web app manifest, and the security guarantees that they provide are mostly based on existing technologies like CSP, cross-origin isolation, and permissions policy. But
I do fundamentally rely on the same origin policy for most of the details.
Yes. Yeah. IWAs themselves do not break the same origin policy. They rely on them. So there are a few changes we had to make, though. So the most noticeable change is bundling and signing. So all the resources of your app have to be packaged together into a signed web bundle, which is a single file containing basically your entire site. And it needs to be signed by a key that right now you manage it on. I'll get back to the key in a little bit. There's also strict CSP that we enforce on all documents within the app. Now, the strict CSP combined with the bundling means we have a fairly high degree of certainty that all of the code executing in the app came from the bundle and can be inspected. There is a bit of an asterisk here because that's technically not, you can never actually guarantee that. When you can ship a JS interpreter with your RWA and use that to implement eval. If you work hard, you can work around some of these restrictions, but they make it extremely difficult to accidentally have other code running in your RWA. We also have isolation. This is both process isolation through cross-organ isolation, which is mandatory, and then there's also storage isolation. This is very similar to storage partitioning, where you basically double key all your storage. We don't actually do that though. We use storage partitions, which are a slightly heavier weight solution and provide slightly stronger guarantees that we're separating the IDWA from your money. Other changes, these don't live on HTTPS. These IWAs live on a new scheme, isolated app, which avoids naming conflicts with HTTPS resources, which can be very tricky to work around. Okay, so we have a new scheme, that's great, but what's the host name? The host is derived from the public key that you would use to sign the bundle. They are not based on DNS or any other centralized naming system. It's just a function of your key. So what do you do if you lose your key? That's a great question to ask at the end. So they also have to span an entire origin. The security boundary of the web is the origin. So there's a one-to-one mapping between an isolated app origin and an individual app. So another problem you run into is, well, if there's no server, like if you're not actually talking to a server, then how do you update the app? And we have an update manifest for that. It lists versions and URLs of bundles. The browser will download that periodically and say, like, okay, there's a version 1.1 is at this URL. I'm on one. Okay, I'll go download that bundle and install it. And then the last feature I want to call out is high watermark permissions. So typically on the web, permissions policies are normally, you start out with all of them, and you can either restrict permissions through a header or an iframe allow it to do. In IWAs, you start out with no permissions policies. And you have to declare the permissions policies that you will use in your manifest in a new permissions policy section. Importantly, this permissions policies are different than permissions. Like if you declare geolocation in your manifest, you do not get geolocation permission. You will be allowed to request that permission, and the permission prompts will still be shown. So, okay, sorry, I meant to have another slide here. But like, putting all that together, you have a single file containing all the resources of your app. You can't load anything else from outside that. You have your own special scheme based on the key you own, and the permissions, however, permissions helps ensure that the APIs that you use are auditable by whoever's going to be audited or it's to look fun. Okay, so that's great. Can you use them? Actually, yeah, you can. We shipped isolated web apps to stable and M128, but only on managed Chrome OS devices. So that means enterprise admins can choose to install an IWA on a Chromebook that they manage. Wider launches, like to other platforms or to unmanaged devices, is further out. We don't have an ETA for that. And earlier I talked about using IWAs to gate APIs. So an example of some APIs that we are planning on gating behind IWAs, you have direct sockets, unrestricted WebUSB, controlled frame, which is basically a web viewer, like a fancy iframe, and get all screens media, which lets you capture all of the screens on the computer instead of just one. There are some others that we're working on that are not as far along, but these are the ones that are either shipped or are close to shipping. And these give you a taste of the types of features that we are that we're only going to enable on iDevice. Okay, so how do you make an IWA only API? Short answer is you don't. You work really hard to make your API available everywhere. That is still the expectation. IWAs do not change that. They are not a get out of jail free card. They are only used as a last resort if you cannot bring your API to the open web. But if you've tried really hard and you still know that the API is only appropriate for IWAs and you have approval for it, you implement the API in Blink like normal. There is one counterexample to this, which I'm not going to get into. But in general, implement your API in Blink. Define a permissions policy for it, because permissions policy is what will ultimately control whether the IWA, an individual IWA, will have access to the API. So you have to have a policy for just your API. And you throw the isolated ideal attribute. So what is this isolated context thing that I just threw out there out of nowhere? So isolated contexts, which I linked to here, which helps no one. They are specced to define a certain level of isolation and integrity. Those are the two properties we're looking for. So the integrity section of the spec is sort of intentionally vague. We deliberately list out the security requirements that we're looking for to enable these APIs and define a method for a user agent to check for those security restrictions. Now, IWAs meet the bar specified by isolated contexts, which is good, but they're not the only possible implementation. The reason I call this out is because there are other efforts that don't quite meet the requirements yet. So one example is the code verify that Facebook has, that they worked with in Cloudflare on for WhatsApp and its web resources. That can do integrity checking. It doesn't quite meet these requirements, but it's sort of close. And that general approach could potentially provide similar levels of guarantees about auditability and isolation as IWAs. There are other Chromium-based platforms like Electron that also have packaging and signing that are also very close to providing the same types of guarantees that IWAs provide. So, okay, apparently that's it. Half of you missed half the talk. I am sorry. Is there anything I should go over again? I feel like a lot of the initial motivations behind it were
Do we want to talk about what this enables fundamentally?
So, okay, yeah, we can. Do you mean like repeat that, or is there an aspect of it that was...
Or maybe do you have a demo?
Oh,
sorry. Counting the gods.
Demo.
Here's a high wire. Can you dance?
So, someone give me something else to talk about while I prepare the demo.
I was curious, just one specific question. You mentioned the multi-screens API. Is there some reason we feel that exposing a single screen is safe, but exposing multiple screens isn't?
Yeah, so it's not so much about the fact that it's multiple screens. It's more about the fact that that particular API doesn't have the permissions prompt.
Oh,
that's the piece, and that's, yeah, I think everyone's like, wait, what? Why?
okay.
There are regulatory reasons why that is a requirement for a lot of people, apparently.
Okay.
And obviously, our response to that was no, we're not doing that. And like, well, okay, maybe in IWAs, if because we know exactly what's going to use this, it's not going to be available for everyone.
Yeah.
The that case is a really interesting one because it's that API is that so the multi-screen capture API is basically a version of get user media that or get
Screen
get screen whatever the API is called that does two things. One is it lets you get multiple screens at once. And well, you could say, well, you could design a version of that API that just let you select multiple screens. But the other side of this is that the developer needs to know, this is where Ramu's alluding to like regulatory things. If this is being used by something that's like capturing your display for like auditing reasons, you need to know that you're getting all the screens, not just the two where the bad things aren't happening. You need all of the screens.
Yeah.
So that lack of user choice is already sort of a first like concern. Right. It's concern about this. And it's also enabled by enterprise policy. And again, we have enterprise policies for enabling permissions. So that's not so bad. But it's when you combine, okay, we've got an enterprise to control this thing, and this thing also doesn't have a lot of choice involved. That it's sort of the intersection of all of those requirements lands us in a place where the API is very abusable. It creates this sort of attractive nuisance of capability, which is where the IWA security model is very helpful, because when you have something that is a very, very attractive to an attacker, we want to make sure that the environment that can use that capability is not under the control of man.
Is that a question?
No.
One aspect of some of these designs is that you may start in a place where you've tried very hard and you have not figured out how to expose something on the web, and you believe that there might be a subset that could get there, but you know that you need to get something out, and this may be a path for some of those.
Sorry, I know I should know this. I'm sure it was like one of the first slides, but IWAs are only deployed on Chrome OS today. Right.
Yeah. Managed Chrome OS devices specifically.
There is a big conversation which I don't believe is yet sorted out, which is what are the trust roots that are respected by various runtimes, right? So like if Edge ships IWAs, do we respect IWAs that are signed by a Chrome signing key, right? Or a Google signing key? Those are questions that I don't believe we have not set up a governance system to manage yet.
That hasn't resolved. So that's the big issue with unmanaged devices. Like for managed, okay, the enterprise can set it up. That's easy. But for unmanaged, you really want the bundle to be countersigned by someone, so that you know that that's essentially the attestation that I mentioned earlier. And then that's the trust question is if like one company countersigns it, does the other company trust it? But you can actually stack those counter signatures. Well, that's the plan, is to be able to stack them. So you could have multiple. That's something that's going to need a lot more discipline. Jace.
Robbie, you might have a demo that you want to do, but just letting you know that I've got a control frame demo teed up. Do that. So you just let me know if you want me to hop on.
Okay. Okay. I can give a quick demo. This is a black screen. Okay, this is a Telnet app. This uses the Direct Sockets API to connect to a server.
It's in a nice app window because you can't see that here, but
oh, that's right. It's in a PWA window.
Yeah.
That's actually another thing about IWAs. You can't open them in tabs. We don't want the user to think of these as normal websites. We wanted the users to firmly say, like, these are apps. These are not tabs. These are more powerful than a regular tab. So it's always in an app window. I don't remember the URL of the Star Wars Telnet demo.
If it's still up, it's towel.
Like towel?
Like towel.
Okay.
Don't forget your towel. Lincoln Lights.
Blinkin?
BlinkEnLIGHTS.nl.
NL.
NL. Got it.
Shipping 422. Yeah.
Okay. Let's see if this works.
God's not kind. Sorry.
Backup demo, please.
I might be able to fix this. We'll find out.
We recently changed a bunch of like in the process of shipping direct sockets, we made some last minute changes to direct sockets. So if your app is just right, then it can fail in projects like that.
Is the issue here that it doesn't have USB unrestricted?
Oh no, it's not USB. It's this is-
Sorry, I was thinking of something else. Yeah, you're right.
Socket API was respelled.
Private network access, maybe.
I think it's the direct sockets blink feature,
Okay.
which I can't restarting the Chromebook. Anyway, can you please demo control frame? Though this is
Yeah, I'll get that set up. There's a
TCP
question on the
socket.
chat.
That's the name of the API. Great demo.
You just imagine Star Wars happening.
Exactly.
It's deep space right now.
There was a question in chat.
Oh, sweet. What was it? Sorry, I missed it. And my Chromebook's restarting, so I can't see.
I think it was about TPM access, maybe in isolated web apps. Like I said, a potential API.
Okay. Maybe. So we are looking into smart card access, which is, I suppose, sort of related. Is it literally the same thing? I don't know.
So there are like three or four layers of web abstraction you can use to access something like a TPM. The web smart card API might be a good thing. There's a proposal floating around for a general sort of like device managed certificates API, which I think should go under IWAs. But we'll see.
I have a question. If another organization was interested in IWAs and having them work on more than managed commerce devices, how might they engage?
Well, they should start by reaching out to IWA-team.
No, -dev.
Well, okay.
Chromium.
Yeah, I guess. Oh, we have a public one too.
We
Yeah.
have a public
IWA-dev@chromium.org.
And would you be open to other people contributing? Maybe.
Yeah, I think we would.
Case, do you have a demo?
Almost there.
Okay.
Sorry, this was a very last minute talk, so I apologize for not having things ready.
So what's the current list of, oh, sorry, go ahead.
You can get
No,
a
please.
question.
Please.
I was just going to ask, you mentioned that isolated web apps are always shown in their own like app window.
Yeah.
What is the rationale behind that?
So the rationale is IWAs are a lot more powerful than a regular website. Partly it's that we want to make sure that users, so when users see an app, they go into it with different expectations than a website. Like websites are more limited. That is generally what users are going to expect. Apps can do more powerful things. If a tab started randomly like accessing devices in a way that they aren't used to, that's not only bad because it breaks user expectations, but that also can erode the trust of the web just in general, which is another thing we have to be careful about. So we do want to make sure that we keep separation between like these fancy APIs are over here and regular websites that are expected to always be safe no matter what are over here. So that's the main motivation for it.
All right, Trace, take it away.
Sure, yeah. So this is what you're looking at is my desktop. And on my desktop, I am connected to a CloudTop instance that's running in Google's compute facility. So this is a Linux system. And on that Linux system, you can see that I'm running a build of Chrome. So this is just from a more recent copy of the tree. But it's running basically code that's been released in recent milestones. This is a view of the Chrome apps interface. So it's the same interface that we had been using for PWAs. And I've already installed a demo test app. This demo test app is available at a particular site for the controlled frame repository on GitHub. So if you're interested in looking at that code, you can go there. You can see that. Let's see if I can remember it by heart. Controlled Google, I think. What is it? YCG. Controlled frame. And so in this repository, you can find the test app. And in the test app, we have the manifest you might be interested to see before I run this thing. Is that legible?
Yeah.
Can people see that?
Yeah.
Great. So you can see here some of the things that Robbie mentioned, but I want to call out permissions policy, right? And so there's a controlled frame permission policy as well as cross-origin isolated that's been granted to this application. It lets us access this API. How much of this do you want me to show, Robbie? Do you want me to show installing an app? Do you want me to do that stuff? I can just launch it and play around with it.
Launch it and show a little bit about what control frame can do.
Sure. So this is the test app that we have written. It helps us verify the controlled frame API. So with this controlled frame API, we can embed content from any site available over some known schemes. So we're only allowing a handful of schemes to be embedded. But we could, for example, embed google.com, and we could change that if we wanted to embed any other website. So we could,
Including websites that generally opt out of being iframed in, right?
Specifically,
Exactly.
one of the things that's fancy about control frame, the frame there is treated as a top level frame. It thinks it's a top level frame, and you have basically web view level controls over it.
Which a regular browser can't do.
Correct.
Right. So this API doesn't. It's the simplest way to describe it is that all of the content security policies that are in place that the whole web stack is built around. This is sort of ignoring all of them. It wraps the Chrome Apps WebView API, and that is built on something called Guest View. That's a component that's part of Chromium. So it just gives us total control to be able to embed content in this way. The API itself lets us set, for example, the source of the embedding control, but it gives us a lot of other freedom to do additional things. We can interact with the network stack. We can watch as requests are going out from this embedded control to as a part of its load or different steps in the network load process. There's authorization hooks that we can get it into, and we can interact with the embedded page in that way. We can run JavaScript on the page. We can execute JavaScript in the context of this page. We can do it while the page has been loaded, or we could do it in such a way that that JavaScript is always loaded when the page itself loads. And then because you're running in a way that this page does not have any awareness that it's being embedded, normally if you were to embed a page, it would have a concept that there's a parent that it's not itself. And in this case, because the embedded content sees that as if it was loaded in a tab, the parent is itself, it thinks that it's in a tab. It's not been iframed. It's not been opened in some new page, and it's subservient to some other content. So because of that, it will not be aware of its state, but you can inject script into that page, and then you can have that script rendezvous with the embedder, and then communicate using post message. And so, say that again.
Why is this important? Like, who's going to use this aside from malware or others?
Yes. So we have some partners that we're working with that are interested in using this, and like one of the use cases for this, we have all the use cases written out in an explainer, but one of the use cases is for virtual contexts. There are other use cases around kiosk. So there are some applications where we want to run content, and we don't want that content to have total control of its environment. So in a kiosk environment, we want to say load something that might be an application that is really restricted, but then can communicate out in specific ways to an embedder control. So there are a lot of BYOD cases for kiosks, like bring your own device. So maybe a student's bringing a certain type of computing device, and they might otherwise control that computing device, But when they run this content, we don't want them to control that because maybe they're being tested. And so we want them to be able to interact with a test application that's an exam, but then they can't do other things they might be able to do on a normal web page, like copy and paste or interact with the text in some other way.
Extremely powerful.
So one other thing to note here, this is running on Linux. Well, he's running a Mac, but he's connected to a Linux machine here. We have launched it on Chrome OS, but it actually does work across platforms. So if you want to play around with it, you can test out IWAs on any platform that Chrome supports. Not all the APIs that we've implemented support all platforms yet. Like dark sockets, control frame, those should work anywhere. Certain other like windowing related APIs will only work on Chrome OS. But in general, if you want to mess around with it, you should be able to set the right flags and enter dev mode. Everyone. Yeah, this is the dev mode UI. We're working on making it prettier. Sorry. You can install a bundle through this UI or test uploading it. We have developer documentation that we can link to.
What other IWA APIs are queued up, Robbie, that might be interesting to talk about?
Right.
So what's
So
the list that's available now and what's coming soon?
so shipped right now, I believe it's just unrestricted web USB. Direct sockets and get all screens media, so capture all the screens. Those are coming very soon. Controlled frame is also coming relatively soon.
An unrestricted USB gets you all kinds of devices that might otherwise be filtered by the OS, including like keyboards?
Filtered by Chrome. Like by default, WebUSB gives you a very limited set of devices. I think they filter in device class. Is that right? Yeah, and WebUSB just unrestricted removes that restriction. Okay. Any other questions or lunch?
I guess, do you know the main sort of like untackled unknowns for if this was to try to be launched on other platforms or different install methods?
The biggest issue is the unmanaged case, and that comes down to the signing and the governance around how do you actually, like, who do you trust? So there's a countersign.
But if we had, for instance, at Microsoft enterprise admins who were deploying applications, because that's the thing that sometimes happens, and Edge supported IWAs, there would be a path today, effectively, for most of these APIs, except for the windowing ones, it sounds like, where we'd have to do extra work.
Yeah.
Cool.
Which I'm sure we would accept.
Patches?
On. Yeah.
Cool.
So, yeah, there's definitely a path forward there. And then I guess the other, actually, but yes, there's a path forward.
I'm guessing UX in general, if it was a user install, would be.
Yeah, we actually have a installation UI that we built out, like an install wizard, basically. And even though these things take like a millisecond to install, the main goal there is to add friction to make it clear to users that like you're actually doing something with consequence here. Like this is an app.
Intentionality.
Yeah. Convey that.
A couple quick ones. What Jay said at the end, like one of the use cases was like for like academic testing in that scenario. How does DevTools play into that? Could like DevTools, could students use DevTools to bypass what's going on there?
Yes, which is why DevTools are generally disabled on school Chromebooks.
Yeah, this is the testing use case is a combination of a number of other administrative controls you can apply to the browser to lock out things like DevTools and put the device into a mode where it's only showing this application, and then within this application you'd use something like control frame to display the actual content that you want to present to the user. So this is like a piece of that entire sort of high stakes testing stack.
Got it. Thanks.
You another.
Yeah. You mentioned that control frame was built on top of WebView.
Yep.
And I guess some of us had naively thought that WebView, once Chrome apps were fully gone next year, WebView is going away.
That is not true. So partly because control frame. Also, so actually some like Chrome UI that uses it as well.
Chrome internally.
Chrome internal UI, like native Chrome web pages and things that use it.
Okay.
So there aren't actually any plans to take it away or to rip it out.
Okay. So
Is that good or bad?
there are some we've had to disable some tests that were breaking downstream. And we just stopped looking into them because like, yeah, it's just, it affects Chrome apps. We don't care. So I needed to review that.
Anything else?
Yeah, one last one. You mentioned when I first came in around the signing, ensuring the content was validated. I'm curious around post install when the app is self-downloading content. Like, what kind of integrity is happening around there? Like, it seems like you'd want to allow apps to get additional content that it can run offline. So
yeah, we don't like block fetch or like we don't block all network access, though that has been a feature request. But we rely on CSP to enforce that. So you can still download images externally. The main thing we're blocking is executable content. So scripts and CSS, which we basically treat as executable from a security perspective, those are not allowed to come from another origin.
Can I jump in briefly? Yep. If you want to build an application that downloads content and, for example, puts it in a controlled frame, and then you provide access, you like proxy access to these more powerful APIs, you could do it. Like you can design a broken application. It is not.
You can't solve culture problems.
Yeah, right. Yeah. So what it does do though is it means that if you're trying to produce a secured application and the intent is that it's not going to accidentally be exploitable, then the boundary should be in place to make it much harder to accidentally have misuse. So it does require that the overall application architecture, be in alignment with trying to be a secure application. And it would go to the auditing process to back that up, right? So we have had an application proposal that raised concerns because the idea was, oh, we already have an existing web application and we want to just embed that, but we need additional powerful APIs. So we'll just proxy those through. And we said, well, hold on, we need to talk about that architecture and how we're going to make sure that you can limit the ability for anything to be exploited. And you have an understanding of what is the trusted application code versus the untrusted fetch from web and updatable.
A more prosaic and maybe less satisfying way to say this is that this is only as secure as Chrome apps ever were. So,
I also think that for people very interested in having like never escape package code, I think that's almost possible with cores. You could say restrict to same origin only, and because this thing is its own unique origin, then you couldn't fetch anything outside of the package because
Yeah. To like Robbie's comment about like people asking for no network access, like by putting the bundled content on its own origin, putting the trusted content on an origin, we then mandate a content security policy that at least limits you to only loading executable resources from that origin. You can load other resources from anywhere you want on the web, the way that any web content can. You have to optionally restrict yourself beyond that. You can say, no, I can't load images from anywhere else. I can't load, I can't fetch anywhere else. That almost gives you the ability to have a web app that actually turns off its own network access. And basically the only thing that you can't currently turn off because CSP doesn't support it is the ability to just open a tab on some other origin. Like that's the CSP directive we'd have to add to actually fully enable an application developer to completely opt out of any outbound network traffic at all.
interesting.
Like the reason that was requested is someone wanted to say like I want to make an app that like tracks money usage, and I want to be able to like maybe distribute it as a bundle that you can run offline and say, I promise you this won't steal your data because like you can look and like it doesn't have network access. So that's one use case for it. And that actually is another interesting direction to take IWAs is if you don't give them any special APIs, then it's just a packaging format for a website that you don't have to host and it can just be run anywhere. So it's another use case that people seem to be interested in as well.
Probably, we're over time a bit.
Yes.
Yeah, we should probably move on.
Okay, thank you, everyone.
Thank you.